everyone, welcome to another math class with Victory. I am glad to have you with me today. If this is your first time coming to my page, my name is Victory, or you can call me Love. I'm a picker, a mathematician, and a child of God. And today we are going to be learning a very interesting topic. Now, this topic was taught in SS1 around 8th, 9th week, the ending of SS1 first term. SS1 first term around 8th, 9th week. And the topic is sets. So the topic we are looking at today is sets. Now, when we talk about sets, a set is a collection of well-defined objects. When we say sets, we're talking about a collection, a family, a group, a team. Now, anything can be a set. As long as I collect things and call them one, they are a set. We have different kinds of sets. A set can appear in different forms, and that's what we want to do today. If we are able to introduce what sets are and explain better what we mean by sets. In sets, we use capital letters to represent sets. Most times we want to note what sets are, we use capital letters to represent sets. And then the elements of the set, we use small letters. So I said, if I want to note a set, like there is a set of natural numbers, this is called a set of natural numbers. Another word for this is counting numbers, if you don't want to say natural numbers. So there are those numbers we count with. So you can, some include 0, some don't include 0. Okay, let's not include 0. So let's start with 1, 2, 3, 4, 5, 6, 7, 8. You know, I can continue this. It doesn't end. How do I say this? We don't know where it could end. So in mathematics, when we don't know the end of a thing, we use 3 dots to show it, and I'll close my brackets. Now, did you notice the brackets I'm drawing? Look at it. See what I'm doing. Now, this bracket is called a coily bracket. Say it with me. A coily bracket, like coils. Coily brackets, or you call it braces. This is a coily bracket, or you say braces. Now, this is what we use to show sets. If we are talking about a set, it must be inside a coily bracket, or you say in a braces. You don't use these other brackets. No, I see people using this. This has a representation, it does a mass. When I use this, it's either I'm just writing my normal English, but in mathematics, this represents interval. And this one too is an interval, but closed, while this one is an open interval. So we use coily brackets or braces. You just try and draw it. Try, at least make it coils. How do I say? Some other people used to draw like this, or even you see in class, you see students making a lot of funny attempts. But we use coily brackets to represent sets. And another thing you should take note of, look at my natural numbers. Did you notice I'm using a comma to separate each of the elements? Now, those numbers inside these sets, we call them elements. Elements are like the members of a set. So when I say elements, I'm talking about the members of the set. So I'm using commas to separate the members of the sets. So that's what I mean by, that's why I'm using commas here. Now, if I have a set, let me say the set is A. If I have set A, and set A is 1 and 2, and I write it this way, set A is not having 2 elements according to what I've written. Set A is only having 1 element, and the element is 12. So if I want to show that it's having 2 elements and the elements are 1 and 2, I must use a comma to separate it. Without the comma, I'm just saying that it's just 1 element. I don't know if you get the point. So we use commas to separate our sets. And when we don't know the end of the set, we can use 3 dots to note it. Another time we use these 3 dots is, let me talk about set of alphabet, English alphabet. We know our English alphabet. Let me say that A is a set of English alphabet. This is something like A, B, C, D, E, F, G. I'm tired, I'm lazy. I agree, I'm lazy. I don't want to continue. So what do? I use 3 dots. Now this three dots is telling us that it did not end at G, it continues. But because I know where it ends, alphabet ends in Z, right? So we know where it ends. I will just continue S, Y, Z. So what I've literally done is I've used these three dots to cover for the other alphabets that I was lazy to write. So mathematicians most times we like doing fast. So we know what is inside there. We know the end, we know the beginning, but we just don't want to write it all out. So we write it that way. Sets can come in different ways. We have countable sets, finite sets, infinite sets. Now when I say countable, you know what we mean now. A set that you can easily count the elements. A set you can easily tell how many elements are in it. And that will bring me to cardinality. Now, when you hear cardinality of a set is asking how many elements are in that set. Like if I ask for the cardinality of A now, this A, the cardinality of A, in A is a set of English alphabets. That means the cardinality of A is 26, because we know we have 26 letters of the English alphabet. And then here, this other A is 2. We have 2 elements in A. So the number of elements in A, that's the cardinality, is 2. So when you hear cardinality is talking about the number of elements in a set. So back to that. If we can easily tell the number of elements in a set, we know that that set is countable. But look at this one. I can't easily tell how many elements I can call natural numbers. These numbers can continue to 1 million, 3 million, 14 million, whatever. We don't know where it will end. That's why we are seeing that 3 dots. It's called an uncountable set. We cannot easily count it. Then another term we also need to get used to is finite and infinite. Now, when you hear infinity means no end. So the idea I want you to remember this with is a set is said to be finite if I know the beginning and I also know the end. If I can tell the beginning and the end, that set is finite. Like this one, the beginning is 1, the end is 2. This one, the beginning is A and the end is Z. So if I can tell the beginning and the end of a set, the set is said to be finite. And the beautiful thing about it is that most finite sets are countable. Finite sets are always countable. But a set is infinite if you can either not tell the end or the beginning, or both. If I don't know the end of a set or the beginning of a set, or even both. Example, look at this one now. If I have this set, let me use this. Let me use numbers. 1, 2, 3, 4. Boom, boom, boom. That 3 dots. Just like this case. We don't know where it ends. That 3 dots saying it continues, and we don't know. They're not telling us where to end. So this set is infinite because we don't know the end. Another example is if I have 3 dots first, -2, -1, 0. Now this is a set of negative integers. Can we see that? Negative whole numbers. It's a set of negative whole numbers. But we don't know where it will start from. We don't know if it started from -100 or -1 million or -20. What we just know is that they are negatives, including 0. So this set is also infinite because we don't know the beginning. Another example is if I also have -2, -1, 0, 1, 2, Now this one, I don't know the beginning. I don't know the end. So it's also infinite. So when you don't know the end, it's infinite. When you don't know the beginning, it's infinite. When you still don't know the end and the beginning, it's also infinite. So this is what we call finite and infinite sets. Finite and infinite sets. So remember, we've talked about cardinality, which is the number of elements in a set. We've said we use capital letters to show sets. If I must write a set, If I say set B, it must start with a capital letter. Then the members of a set, the numbers we are writing inside the set, are called elements, and we use this to show elements. We use this. In fact, let's look at the different symbols we can have in sets.